So I'm just gonna summarize some of the stuff I did that I thought was either cool or stuff we did outside of that we might not have covered in class or extra credit. So I had some data that I cleaned. One thing I thought that we didn't really do in class was instead of just filling in this missing numerical value epsilon with uh the median, this k like and I think like closest neighbors, it looks at the k, in this case k was 5, closest neighbors in the data and replaces the missing epsilon values with the average of those. So like the alpha, beta, gamma, deltas are similar, then it'll average together 5 of those and then replace a missing epsilon value with that. I guess it's more, I don't know, intelligent way of doing it rather than just finding the median and replacing all missing values with a median. Hugging Face. I gotta run this one while it's running. Multi-class logistical regression. So like logistic regression we did in class, just with multiple classes instead of just yes, no, or 0, 1. So here's the confusion matrix. This is a small data, so I had perfect scores. I did again with this dry bean data set, a bit more trained the data, with the data, trained it on part of it, and then tested it on the other part. SQL, I just had imported some, I had some standard data one might do. The pretty basic queries. Here I ranked them for each class. This one it's kind of like a if this then that case in SQL. So depending on what their grade is, they'll get a certain letter grade. Polynomial regression. So this is similar to linear regression, just what if the data is random? Well, then linear regression doesn't work out so well. So R squared is 0.1. It's terrible. Basically, it's 1% of the data, that's nothing. But for a logistic model, regression model, where the degree is 5, we explain 82% of the data. That's pretty good. For the residual plots, this not good. This is a bad looking residual plot. This is good looking residual plot. I guess it's not a perfect, but it's really good. Yeah, you don't want to get too high of a degree because then the data you train on it adapts to it too much. You want a more simple model. So that's why the MSE actually goes up once you get too high in degree system. So in Hugging Face, I made this image processor. I mean, I made it. I just pretty much imported most of it. So I could just like take an image, upload it, and well, I'll try some more difficult. Figure out what car it is. Some car brands. So you give it some candidate labels, and it'll Prius. Alright, well, it'll predict. It'll assign probabilities for each candidate label to predict what the car is, and it's pretty confident it's a Ford. Here is a question answering program where you just plug in a block of text. This is like some sort of storybook, part of a storybook Wikipedia page. You can just ask it questions about it, like how many Nobel Prizes. It says like 2 here, so gives you a confidence score on how confident it is. And then the last thing I used Hugging Face for was the summarization model. You just plug in some article text you just want summarized for you, and the AI will try to summarize it. So that's it for my project. Well, that I